Hello, assalamu alaikum. Can you hear me? Hello.
Alaikum salam. Yes, we can hear you.
Yeah, how are you?
Alhamdulillah, it's been busy. How's it going?
Yeah, alhamdulillah, everything is good, but very busy time. Okay, just we are waiting 1 minute, then we'll start.
Inshallah.
Okay. Okay, welcome. So I think all of you already get the previous material and also practice. Yeah. And also try to do for LST and NDVI correlation using Landsat satellite data. Or if there are any problem, then also inform me. I'll try to guide you. No problem. How we can easily make the correlation analysis. So previous time I discussed about the modis, how we can easily apply the modis. Okay, but modis have some problem for the small study area. But when you work with big study area, then we can find out the more better result. Okay, for the Landsat satellite data. Okay, I think some person is not joined yet, so we will start. No problem. Okay, so they can collect from the recorded classes. No problem. Okay, so we'll start today's session. So basically today I discuss about the three topics, mainly how we can easily work with drought monitoring. Okay, it's very important. Okay, suppose different types of drought monitoring indices, suppose vegetation condition index or vegetation health index or temperature condition index. Okay, as well as we also discuss about that surface based aridity index, how we can easily monitor. We also discuss about that. And previous time we also discussed about the one machine learning topic. Suppose how we can easily work with Python for making the land use land cover classification. So it's not completed. Just to discuss about that how we can easily collect the image and how we can easily use the image and data, mainly training sample data. So today's session, inshallah, I discuss about that how we can easily implement this type of data and apply the machine learning to make the land use land cover classification. Okay, so let's go start. Let me share my screen. Okay, so let's go start our today's session. So let me open a new code editor. Okay, can you see my screen? Yeah, can you see my screen? Is it visible?
Yes, it is.
Okay, thank you. So today we discuss about the three topics, mainly how we can easily work with the drought monitoring using the two ways. One way is that sub basically surface based aridity index, how we can easily apply and identify suppose hyper arid region, then arid region, then semi arid region, dry sub humid region and normal region. Okay, so this thing I will try to explain. Then we discuss about that vegetation condition index. Based on the vegetation condition index or temperature condition index or vegetation health index, how we can easily identify the drought. Okay, and then how we can easily make the drought classification. Okay, for the using this type of data. So you can see this is the vegetation condition index, this is the temperature condition index, and this is the vegetation health index. So then we try to use this all of index and then make that drought classification. Okay, and identify extreme drought condition, severe drought condition, moderate drought condition, mild and no drought condition. We try to identify. Okay, and after that it show the drought condition for the overall all study all region. But if you want, you can also select for a specific study area. Suppose I want to identify only for the cropland. Okay, only for the agricultural land. Okay, so further we also try to max with the agricultural land vegetation health index. Okay, agricultural land VSI. Okay, and then drought classification only for the cropland area. Okay, so now this is the layer, first layer, only for drought classification for cropland. Okay, only it's just max only for the cropland area in Bangladesh. Okay, so this data you can easily generate different way. You can make the land use land cover classification, or you can use the ready-made land use land cover data. Different types of ready-made data you can also use. So now this is the result. It just show you only for the cropland condition of drought. Okay, just we simply make the road classification only for the cropland area. So that's why I just simply connect with the land use land cover of the cropland area, and then max with the road condition, then we can get this type of result. Okay, so I'll also discuss about this topic also, then you can get the better idea, and you can also use it for your own study area to identify road. And if you check okay, so this part, so previous class we discussed about from here, so how we can easily import the satellite imagery. Okay, and also import the training sample. Okay, suppose you can see here I imported the build up, then water body, vegetation, or barren land. So this type of training sample I already imported. I already show you this process. So now we try to use it and make the final classification of land use land cover classification, and also show you the accuracy, how we can easily make the accuracy about the land use land cover classification. We also discuss about that. Okay, so let's go on by one. I try to discuss about all of topic, then you can easily get the more better idea. So first of all, we discuss about that VCI, TCI, and VSI. So these three index is very important for the drought. So if you simply check some scientific paper, so let me show you that for scientific paper. So simply search here. Simply go to the Google Scholar. Then we find out a lot of scientific paper regarding this type of index. So simply search here, suppose drought condition or drought monitoring. So PCI, TCI, and VSI. Simply search. So then we find out this type of paper. So if you see, this is the one kind of paper. They are used at the VSI, improving the drought monitoring capability of VSI at the global scale. Assemble index various vegetation types between this time period. They are also using here. So in this paper, they are also using at the vegetation health index. Okay, and they are use it for the whole study area. Okay, basically whole world. And in this paper, you can see we can find out some drought index or estimation. So this is the formula. It's called the VCI. VCI basically vegetation condition index. So this formula is that NDVI minus NDVI minimum value divided by NDVI maximum value minus NDVI minimum value. Then this is the TCI. TCI basically LST maximum value minus LST divided by LST maximum value minus LST minimum value. So this is the TCI. Okay, this is the VCI, this is the TCI. And after that, just use the VCI and TCI, compute the vegetation health index. So here we already know about that NDVI and LST. We already know about that how we can easily compute the NDVI. So previous classes I discussed about that we can compute the NDVI using MODIS or Landsat. Okay, so Landsat is more better than MODIS because Landsat is high resolution. So if you want, you can also use this type of NDVI LST using Landsat, no problem. You can also use the Landsat, or if you want, you can also use it MODIS, no problem. Because both of data set we can easily use and then compute the NDVI and LST. So for that, simply compute the NDVI minimum value and also compute the NDVI maximum value for VCI, vegetation condition index, and TCI, compute the LST maximum value and also LST minimum value. Then apply this type of formula. Then we can easily get the VSI, vegetation health index. So I will try to show you this type of process using MODIS satellite data, and further you also try to apply Landsat data, how we can easily apply the Landsat data to monitor the drought or VSI or vegetation health index, how we can easily monitor. So let's go and try to discuss about that, this topic. So here I already write the code. So just I explain the code, then we can easily cover very short time. Otherwise it take a lot of time when I write the code. Okay, I try to explain one by one all of code, then you can easily get the idea how it will be work for the vegetation or drought monitoring condition index. So in this case, we simply, okay, it's a, okay, variable can be anything, no problem. So in this case, we simply import the dataset modis. So for that, VCI, mainly vegetation condition index, we need a indices. It's called the NDVI. We need this indices, and also TCI, mainly temperature condition index. We need the LST. Okay. So this NDVI and LST we can easily generate from different satellite sensor. If you want, you can use here the Landsat, or if you want, you can also use at the modis. Okay, for computing the LST or NDVI, we can easily use the Landsat and modis, and we already know about that how we can easily make the historical data analysis for the Landsat, okay, and make the yearly LST or yearly NDVI. So you already know this type of topic. So in this case, I simply apply this code. I just use here that NDVI data. So if you check this, the NDVI data. So this NDVI data basically the 16-day global, okay, revisit or temporal resolution 16-day, and a bands we find out the two bands NDVI and EVI. So we can easily use the NDVI, and then further we can compute the vegetation indices, okay, from here. So it's a ready-made data, so not need to put any kinds of calculation near minus state divided by near plus state. But when you work with the Landsat data, we need to apply this type of formula. So let's go try to import the data. So this is the NDVI. I put the NDVI variable name, and this is the LST. I put the LST variable name, and further this is the international country boundary polygon. So we can simply, it is stored all of international country boundary polygon in the world. So you can simply use from here, just apply for Bangladesh. So simply I just filter the data and take the Bangladesh boundary, only for the Bangladesh boundary. Okay. So then if you check, just we simply filter, okay, for this Bangladesh boundary. So we can put any name as a variable. Okay, so I put this China, but it's already the Bangladesh, but variable can be anything. It's not problem. So then we simply put the observation time period. Suppose I want to observe the condition in 2015. So 2015 in Bangladesh, what the scenario of the drought I want to identify. So simply put the, take a variable start year and end year. So start year and end year is the same. Okay, just I work only for the 1 year. So you can take the 10 years or 5 years. It doesn't matter. We can put any year in, just simply change the year. So in this case, I just work only for the 1 year. It will be start 2015 January to December. Sometime we need to also work with seasonal, suppose seasonal drought condition. So simply adjust your time. Okay, suppose only for the rainy season what the scenario of the drought, or summer season what the scenario of the drought, simply adjust the time or month from here. So just I put the start year and end year, and take the start month January and end month December. Okay, then we simply create a time frame, okay, or time object or date object. So date object, this format date frame from year, month and day, YMD, year, month and day. So put here the start year, so it's come from here. Then start month, so start month basically it's come from this variable, and one basically first date, 1st January 2015. Then in date, simply in year 2015. In month, basically in month 12 May December, and date 30. So simply we simply define the start date and end date. So now this start date and end date, we need to just we are use this start date and end date and make the filter our collection, basically Modis NDVI collection and also Modis LST collection. So for that, just simply take a variable filter NDVI and call my NDVI. So basically this variable is stored all of image collection for NDVI stored in this variable. So just I simply filter date and put the start date and end date. Okay, simply put the start date and end date. So he's indicating these two variables, start date and end date. And filter bounds with my region of interest, which is stored my boundary shapefile, and select the NDVI band. So then we check how many images we find out for this. If you check it, how many collection. So we find out the total 23 image collection for NDVI. So now same process, just apply Just same process apply for the LST also. Just call the LST, just call the LST, okay, and then filter bounds with the study area, okay, then put the, so in this case you can see here I use the another way to write the code. So in this code, this line number 31 and 32 is the similar with this. If I just only put the start date and end date, so we find out the same result. So in this case I just simply use the another function. It's called the calendar range function. So calendar range function, it filter only for the one year 2015. You can see year 2015, but month January to December, okay, just simply month. So it's just filtering from here. But we already know about that modis data set. We need to mainly we set the year, month and day format. We simply set it, okay. If you check it, suppose let me just print, suppose print this filtered LST and then check how many image collection you find out in here. Suppose LST, run the code. So it's working. Yeah. So now if you check, we find out that 46 images. Okay. So we face a one problem. One problem is that for NDVI for 1 year we find out the 23, but LST we find out the 46 image collection. Okay. So it's depend on the temporal resolution. Suppose this 23, basically this temporal resolution is the 16 days, okay, it's the 16 days. So every 16 days I find out the data, but for LST we find out the data every 8 days. So every 8 days, 46 into 8, almost 1 year fill up. So for the LST we find out the 46 image collection, but NDVI 23 image collection, okay. So it's a problem. So for that we need to use the same number of image collection. Suppose I have a NDVI 23 image collection, so I need to convert this 46 image collection into 23 image collection. Suppose temporal resolution, suppose in this case this is our main goal. NDVI, it has total 23 images, okay, and for the LST we also convert into 23 images, okay. So just keep the same number of images, then I can easily overlay, okay, I can easily overlay. So now how I can keep the same temporal resolution? Suppose NDVI 23 images and also LST 23 images. So for that we are just use a package or package trend. So it will be start from here, you can see. So this is the long package trend. So in this this package start in here, and in if you check, this is a very long code. So this code package trend in here. So basically this function help you to convert the LST into 23 images, okay, 23 images. It's just convert, we find out this imagery. Okay, so it's convert only for the 23 images, okay. So this is the package, because in this time I will not explain this package, so you can use always same package to converting the similar. So in this case you can see in this package you need to define, so you can see it's one kind of function, okay. So this function basically add dn, so it's one kind of function variable. So this function variable I just simply connect with my 46 image collection, then put here the true and put my 16. So basically this 46 image I want to convert into 16 temporal resolution, okay. So just put here the 16, okay, put here the 16, then it just work as a 16 days temporal resolution. We take the data and make the similar temporal for NDVI and LST. Okay, so this is the package we simply use in here. So just I call the filter LST. Filter LST basically destroy total 46 images. 46 images. These 46 images, we just use this function, mainly this package, apply. Now it convert as a 23 images. Okay, so when you work, just try to keep the same temporal if the Lancet or also Modis. So for the Modis, this is the process, but when you work with Lancet, just take the same. Okay, same, because same number of images used for creating NDVI and same number of images also used for creating the LST. Okay, then we can easily get the same number of images, both Lancet and LST and NDVI. But in this case, it's a ready-made product for NDVI and LST. So NDVI, it's provide the 23 images, but LST, it provide the 46 images. So it creates some problem. So that's the reason we simply use this package. So this package manually just convert this 46 images, convert into 23 images. So now if you check finally if you check how many images, we find out that this 46 element, it's converted into 23 elements. Okay, when I add the function, if you check, so we find out that we can see this temporal resolution, it changed. Okay, and we changed based on NDVI temporal. Okay, so 16 days. So now for the 16 days temporal resolution, we find out that 23 images in 1 year. So if you check, this is the image. So basically this image have the LST to 1 kilometer. Okay, this is the band name, and you can see that if you check the date, first image in the 1st January, second image 17 January, third image 2nd February, then fourth image 18 February. So every image, 2 images, we find out the interval 16 days. Okay, but past time it was 8 days interval, so we find out the 46 images. Okay, so anyone any question about in this section, you can ask me, please. Any question? Okay, I hope you can also get the idea. So our main target is that we simply keep the same temporal resolution, because NDVI and LST, NDVI, we find out that mainly your 23 images, because it's a 16 days interval, but LST, we find out the 46 because 8 days interval. But when you work with VCI, TCI or VSI, we just keep the same temporal resolution for LST and NDVI. So simply apply this package print, and then we can simply convert into 46 images, convert into 23 images for LST. So it's very easy. We can get the idea. For the 46 images, convert into 23 images, temporal resolution, because our NDVI is 23 images for 1 year. Okay. After that, we need to convert, because NDVI, you can see, simply multiply 0.001 this value, because we need to reproject the scale factor to get the proper NDVI pixel, -1 to +1. Okay, simply multiply this value, and then scale LST. So this is the 0.02. So this is the scale. So when you subtract this value, then we can get the result in degree Celsius. It's just simply converting this type of things. Just reproject the scale value both for LST and NDVI. And further, we compute the VCI. So if you check VCI formula, we already check about the VCI formula. Now our data is ready, so we can easily apply the VCI formula. VCI formula basically NDVI minus NDVI minimum value divided by NDVI maximum value minus NDVI minimum value. So when I apply this formula, then we can easily get the VCI. So further, we need to compute NDVI minimum value, NDVI maximum value. We already know about that, how we can easily compute minimum and maximum value. Okay, so you can see, just I take the VCI. Okay, so in the VCI, we create a function. Okay, so in this time, these things is represent another way. So compute. Okay, so every images, in this case, we just work for collection. Okay, suppose I have total 16 images for NDVI. Okay, so for the 60 images NDVI, every image every image I compute VCI. Okay, every image I just compute VCI. Sorry, 23 images. So this 23 images, every image I compute VCI. Okay, so for that we create a function. Okay, we just create a function, and in this function, if you check, this function will be start in here. So this is my function. Okay, this function is simply compute or argument what I need. So my argument is that I want to compute minimum value and also maximum value from every images, and this value I also use, and further I just create this type of equation: ndvi minus minimum value of ndvi divided by maximum value of ndvi minus minimum value of ndvi multiply 100, mainly percentage 100. Then I find out what is the ia basically ndvi, then I mean minimum value of ndvi, I max maximum value ndvi, and rename with rename just vci. Okay, and it create the print vci. If you check how many images, we find out that vci, we find out the same number of images, 23 images. If you check in here, so vci, you can see you find out 23 images. So every image I have total 23 images of ndvi. So every image I just convert into vci. So we find out the total 23 vci images. Okay, and what the purpose for doing this? Because I also create the time series analysis or time series chart of every index. So that's the reason I just simply work as a collection. Suppose I have 23 images of ndvi, so all of 23 images I just use and make the VCI. Same process also apply for TCI, temperature condition index. So I have total 23 images for LST. So same number all of images I simply convert into TCI or temperature condition index. Suppose I have total 23 LST. I have total 23 LST map or LST data or LST image. So this 23 LST image just I convert into temperature condition index. I compute temperature condition index for every LST image. So for that, just apply the same function. If you check, so I create a function. So from this function I simply compute the minimum LST and also maximum LST, and further I simply use this equation: LST maximum value minus LST divided by LST maximum value minus minimum LST and multiply 100. So then I simply put what is the all of those and click with that. So now if you check how many TCI, we find out that if you check, we find out the same number of images, 23. Okay, so now my VCI and TCI is ready. Okay, so then I can easily apply the vegetation health index by implement this last formula. So this is the formula we can easily apply. Okay, just VCI plus also this the 1 minus alpha. Okay, if you read this type of paper, you can get the better idea, this type of equation. So let's go try to implement this equation and check the result. So now if you check, okay, so now further we try to display the map. Okay, just add the VCI and TCI map. So if you check this map we create, so this is your VCI and TCI. So this is the vegetation condition index. If you want, you can also stress and get the more better result. Okay, just a minute. Let me share my screen again. Okay, can you see my screen? Yeah, now. Okay, so let's go. So now if you check, we find out this type of VCI. Okay, so vegetation condition index, if you check the condition of vegetation, so this type of, it's, you can see, okay, it's very low condition, we find out. Okay, this type of VCI we find out, and this type of green color, indicating about that good condition. Okay, and we find out this type of VCI map or vegetation condition index map. So you can also download this type of map to make the for your research paper or presentation, to identify only for the vegetation condition. Okay, where is the good vegetation, where is the, so if you simply search here, suppose VCI classification, VCI classification range. So if you check this VCI classification range, so you find out, you can see this type of percentage. So if you check this percentage, basically 0 to 10 extreme drought. Okay, if the VCI value 0 to 10%, it's called the extreme drought. Then 10 to 20% severe drought, 20 to 30 moderate drought. Okay, and 90 to 100 is a no drought. So you can also make the classification, okay, after downloading the geotip file format, this type of range. Okay, so you can see if the vegetation condition 10% or 0 to 10%, it's indicating about the extreme drought condition, and if it's a 90 to 100, no drought. Okay, so this is the VCI. So if you check, suppose TCI map, mainly temperature condition index. So this is the TCI map. So now if you check, just click on here, and then you can see also 0 to 100. Okay, so now if you check for the simply search, suppose TCI classification range, and then check TCI classification range. So you can check, we find out this type of range. Okay. So drought condition, extreme dry, or this one if you check. So you can see, we find out that 99 to 100 ideal, or 80 to 89 excellent. Okay, for based on TCI, temperature condition index. Below 9, impossible, extremely unfavorable. Okay, very unfavorable, unfavorable, marginal, acceptable, good, very good, excellent, and ideal. So you also try to check this type of TCI score. You can see this is another one. Okay, so now we are compute the vegetation health index. Okay, vegetation health index. So this is the two things. Some paper is also work with only for the VCI and TCI, but in this case it's just combine VCI and TCI and make it, suppose VHI, vegetation health index. So that is how we will create the VCI. So for the VCI and TCI, when you work, now we need to combine. Okay, we need to combine these two band in one image collection. So basically this VCI, it's come from single image collection. You can see VCI. So this is the single and this is the another. So now we need to combine. Suppose I just create a collection. So this collection, I find out the two band. Okay, so in this time you can see it's just show only for the one band, TCI. So it's a separate, and also this is the another image collection for VCI. So when you work with the VHI, then we need to combine. We need to combine the VCI and TCI together. So for that, we simply apply a code. It's called the ee.filter.equals, and also join save first. So for that, you can see, just put a function. When you combine, it's a two different band. Suppose it's provide the VCI band and it's provide the TCI band, but it just come from different image collection. So I need to combine VCI and TCI together and make a one image collection. So this is my goal. So for that, we simply apply ee.filter.equals, and then put here the left field and right field, put the system start and also system start, and join. Okay, then join dot save first, then mesh, and then simply apply the join. So just take a function e.image collection, then apply the join. So just I simply call this variable join, and I want to apply it for VCI and TCI. Basically VCI, it store it mainly your VCI band with their collection. TCI, it is stored the TCI band and their collection. So just I simply apply the join in this image collection, and I create a function. This function return the bands, return the add the bands. Okay, basically VCI and TCI band just make a one image. Okay, suppose first image it's have two bands, second image two bands, third image two bands, so all of bands including the two bands VCI and TCI. Okay, just make the combine the two bands. So for that we simply apply this code. You can see both. So if you check, suppose I just print the both and then check what happened. So in this both, this variable is stored 23 image collection, but every image stored the two bands VCI and TCI. So now let's check what happened just on the code. This one. So you can see 23 images, but all of images have the two bands. So simply join. Okay, but these two bands it's come from different collection. So not only for this, anytime you need to merge. Suppose a different collection, different band, you need to merge. Just apply the same process. Okay, because different work we need to merge the bands for the different collection. So in this case, I simply have a collection for TCI and VCI, but calculating the VSI, I need to merge. I need to merge both of collection. So further I simply apply the this apply and join function. Okay, and then we find out, you can see it's create the 23 image collection, but if you check, all of image collection have two bands. We find out the two bands VCI and TCI. Okay, so now using this image collection bot, I can easily compute the VHI, because this image collection including the total two bands. Okay, PC and TCI band stored in the bot variable. So let's go try to check and compute. So you can see it's very easy, just we simply apply this code. So just I create a function, suppose I put the function variable name, suppose img element name, and then what is my argument? My argument is that I want to return this VSI as a bands, but this bands is computing this equation. Okay, so just we apply the expression also. This a1 divided by 2 plus b1 divided by 2. So here a1 is the VCI, b1 is the TCI, and simply convert as a VSI. So now it's create the VSI 23 image collection. If you print the result, just print, then we can get the result. This VCI also have total 23 image collection. You can see 23 image collection, and now it's create the VCI band. Okay, it's create the VCI band. So further I can use the band and make the time series chart. So because my purpose is that every VCI, TCI or VSI, we just create the time series chart. Okay, so for that I just work all of images, okay, using the function. So we find out this is the VSI. And now further, if you want to display the result for VSI, So this is our VSI. VSI basically vegetation health index. Okay, just simply stressing the data to look more better. Basically it's computed 100%, so that's why you simply put the 0 to 100. But when you test it, then you can find out the more better visualization, or you can also download this map GOT file format. So now just apply. So now you find out this type of map. You can see basically this type of place is more drought. We find out this type of color, but green, we find out the low drought condition for this type of green place. Okay, green is indicating about that no drought condition, but this type of color. Okay, if you check the VCI classification range, it will be more better. So simply search VSI classification range, then you can get the different types of classification range you can check. So VCI range, you can see 0 to 10, it's mainly extreme drought. If the value 0 to 10, we find out the extreme drought. 10 to 20 severe drought, 20 to 30 moderate drought, 30 to 40 mild drought, okay, and 30 and more than 40 no drought. Okay, so you can easily download this type of map and further just make the classification using ArcMap or QGIS software, and further you can make this type of friends. So basically this is the way to compute the VSI and help of TCI and VCI. We simply compute. Okay.